Right, physics fans, level 2. We're going to look at projectile motion in 2 dimensions, x and y, based on the game of basketball. You can just see the ball there in Michael Jordan's last ever game in a Bulls jersey, where he beat the Utah Jazz, along with the Bulls, to win the championship in the NBA in 1998. So let's figure out what made him such a good basketballer. He did a lot of practice. Here's one of those shots in practice. He releases the ball at an angle of 40 degrees to the horizontal, and it's traveling at 9 meters a second. Right? And he releases it 3.5 meters in the air towards the basket, which is 6.7 meters away. You got to figure out the maximum height of the basketball above the basketball court, how long the ball spends in the air, and figure out if or not he makes the shot. So if you want to try these questions yourself, pause the video and go for it. Otherwise, here comes the solutions. So, maximum height of the basketball, what you have to remember is he's already releasing the ball 3.5 meters above the basketball court. So whatever we figure out here, we're going to have to add 3.05 meters to the shot. So we've got to do a little bit of trigonometry to resolve both the horizontal and the vertical components of the velocity, which I'm going to call uy and ux. So for uy, that's the opposite side of the right angle triangle, uy is going to be 9 meters per second multiplied by sine of 40, whereas ux is going to be 9 multiplied by cos of 40. Okay, so doing some number crunching, 9 times sine of 40 gives me, let's go 2 decimal places, 5.79 meters a second. Whereas 9 times cos of 40 gives me 6.89 meters per second. So it's gone a little bit more faster in the horizontal, which makes sense because it's above the 45-degree angle. Right. Let's have a look at our vertical data, because that's going to determine what we do next. We're looking for the vertical height of the shot above 3.05 meters, so that's the question. At the peak of the shot, there's an interesting thing happens temporarily, just a split second, where the final velocity will be 0 because it's going up and it's a positive number, 5.79, but in order to come down, a negative number, for example negative 9.8 is acceleration due to gravity, it's going to have to go through 0, positive 0 to negative. So therefore, we now have just our 3 points of data that we need to solve this problem, and I'm going to use this equation, v squared equals u squared plus 2as. Nice one. Now, rearranging this, looks like this, and the answer is going to give us 0 squared minus 5.79 squared over 2 times minus 9.8. Now, number crunching that one gives us a maximum height of 1.71 meters. Now remember, that's from his hand, so your final answer would be actually 4.76 meters, which is the 3.5 meters that his hand is at plus the height of the shot. So 4.76 is the final answer there. Okay, now that takes care of question 1. How long does the ball spend in the air? So to figure that one out, we've got pretty much all the data we need, and we can do this with these 3 bits of data here and the equation. Let's change colors to red. V equals U plus AT. Now, rearranging that, we can get the time up, because remember we only took our measurements to the middle point of the shot. So that will be V minus U over A, which is 0 at the peak of the shot. Take away 5.79 over 9.8, which is a minus number. Therefore, 5.79 divided by 9.8, in going up, the ball spends 0.59 seconds just going up. Multiply that by 2 and we get our total time in the air, the answer to number 2, which is 1.81 seconds, or 1.82 to two decimal places. Okay, now we're doing pretty well here. We've almost finished everything. The last one is determine whether or not he makes the shot. In order to do that, we're going to use our total time, 1.82, and our horizontal velocity of 6.89. Now, much like a lot of problems in IB physics, we're going to ignore air resistance in this case. We've got our answers and our data for question 1 and 2. So what we're going to do now is figure out the last question. Does he make the shot? Well, we know that the basket is 6.7 meters away. So all we really need to do is figure out, where does his shot land? And if it lands at or about 6.7 meters, we're okay. Because there's no drag or air resistance, there is no deceleration horizontally in the shot. It'll keep on traveling at 6.89. In terms of the length of time it will travel at that speed for, it's 1.82. So we've got 6.89 times 1.82, and that gives us a total distance of 8.14 meters away. So Michael Jordan has overshot the basket by about 1.4 meters. So sadly he's missed this shot, but that's okay. He was famous for saying that he missed more shots than anyone else in the world at the time because he was practicing so much. That's what made him so good. There you go.